Okay, now let's look at clustering in SAS. So new project, chapter 15, clustering, and C drive, MGT 4270. Set up library. MGT 4270 and C drive 4270. Okay, create a diagram. Let's call it cluster. And a data source. MGT 4270, and here is the utilities data set that we used with 22 observations. So we'll bring that in. And advanced metadata. Okay, let's look at what we have. And company name, we don't need company name, so it got rejected. That's good. Cost, okay, it's setting role as cost, but it should be input, and the rest of it is input. Nuclear, it says it's nominal. Okay, let's see what the values are. So this is nuclear as a percentage, so that should be interval. And here is another nominal demand growth. Let's look at what that is. And again, demand growth should also be interval. Alright, so let's finish that. Okay, now bring in utilities. Remember, before we do clustering, we need to transform interval variables to, so here is interval variables, default method. Okay, let's use range. So this does range transformation. Okay, then clustering, we have under explore, we have cluster, and then there is variable clustering. The variable clustering is a variable selection methodology, so we are not going to use that. We're going to use cluster. All right, connect that. Okay. Now, the internal standardization, see, you set this to none because we are doing transformations with a transform node, and the reason is this one doesn't. The standardization is it only does the numerator. It doesn't divide by the standard deviation or the range. So we'll set that to none. We are already standardizing here. All right. So we are using the WARD method. This is similar to the hierarchical agglomeration method. This is preliminary maximum. So how many clusters you want to have initially. So if you have like 10,000 records, you don't want to start with 10,000 clusters. So in our case, it's only 22, so that's not a problem. So minimum number of clusters is 2. The final maximum, okay, that doesn't mean that you're going to get 20 clusters, but that's the default, and this will produce the clusters it thinks that is the best. And then CCC cutoff, that's another statistic that measures the ratio between the internal sum of squares versus external. That is within cluster sum of squares error, which you want to be very small, and then between cluster sum of squares that you want to be large. So that's kind of a ratio of that. So let's run. Okay, see the results. All right. So this is your, there are 8 clusters that it's giving. Okay, so if you look at here, segment ID is actually giving you 20 clusters. So there are some with just one, and there are two clusters with 2 observations, and this is a very small example, so we're not going to be able to see how to identify segments. Let's set the final maximum to 4 clusters. Okay, so now we have 4 clusters, right? So here are the frequencies, and then we have the root mean square within each cluster, and then these are the maximum distances from cluster seed, that's your centroid, okay, distances to nearest cluster, and so on. So here is the segment plot that's interesting for us to see. So we have 6 clusters, so we have one plot for each cluster. I'm sorry, we have 4 clusters, so so we have, okay, so we have a plot for each variable, right? So this is the transformed variable, range cost, range demand growth, range fuel cost, and so on. So for each plot, the range cost and each variable value is plotted as a percentage bar graph for each segment. So segment 1, okay, so range cost, the transformed variable range cost is between 0.25 and 0.375, is about 14%, and that one, and that one, and that one. Okay, so this is cluster 1. Now if clusters 1, 2, 3, and 4, they have similar distribution of values, then it is not really differentiating between clusters. And now if you see here, you see range of nuclear, then segments 2, 3, and 4 is very heavily formatted value of 0.125, small, right? Whereas this one has all kinds of values. So segments 2, 3, and 4, they have very low nuclear component of the power generation. So this cluster is clusters 2, 3, and 4, no nuclear. Cluster 1 has some nuclear. So that is one differentiating characteristic of segments. And here again you can see this one is sales. Okay, now how sales is differentiating, you can see these are higher values, 0.8. So remember, these are range transformed, so the values are between 0 and 1. Closer to 1 means larger, closer to 0 means small value. So here is again something we can see. These are cluster 4 is low sales companies. Okay, so these are the clusters that seem to give some. Okay, here again there is another one where you have let's see what this is. This is load factor, and this load factor is 0.625 to 0.75. So it's a moderately high load factor. So you can combine these information: moderately high load factor, low sales, no nuclear. So that's a kind of an explanation of cluster 4 records. So cluster 4 profile, you look at these graphs and figure out, stitch together an explanation. Suppose if the graphs are such that you're not able to stitch together a description of the segment of the cluster records, that means the procedure has not given you something good to work with. So maybe you need to try a different parameter, maybe different k value or something like that. This part is the more interesting part, more creative, and it requires a lot of experience to be able to figure out by looking at these charts what the cluster characteristics are going to be like.